Here we go. Everybody got it? My good old favorite student. So our plan of attack, I'll probably get about half of a lesson done today. I'll finish a lesson off on Monday. Your test is probably going to be next week, Friday. I won't get it on the first report card, though. Yep.
Sorry, could we go on a date for our thing? Because I have to get...
Our thing. Can you use more nouns and less pronouns, please?
Tutorial.
Oh, tutorial. Yeah, we'll talk when we get closer.
No, but I need to know because I...
Yeah, we'll talk, but later on in class, not right now. Yes?
When's your mark cutoff?
June 15th. We'll talk, but let's do the quiz, okay? Quiz first. Shh. How many odd three-digit numbers are there? By the way, I set this quiz up somewhat in the order that I've taught you. In other words, I'm willing to bet the first couple of questions will be fundamental counting principle, drawing a blank, Scrabble bag, or permutations, factorial. Then probably there's going to be permutations with repetitions where there's some letters that repeat. Then combinations and pathways. I bet. Let's see. How many odd how many digit numbers? This is going to be fundamental counting principle. I'm going to draw a blank. 3 blanks, as a matter of fact. How many choices do I have for the first digit?
9.
Why not 10?
Because you can't answer for...
Okay, I'm not allowed to begin with 0. Does it say in the question without repeating? No. So it looks like once I've picked a number, I can put it back in the bag, shake it up. How many choices do I have now? 10, then? Oh, it's got to be odd. I should have done the restriction first. If it's got to be odd, I only have 5 choices because it's got to end in a 1 or a 3 or a 5 or a 7 or a 9. How many odd 3-digit numbers are there? 450. How many even 3-digit numbers are there? Probably also 450, because I think there's the same number of odd and even numbers. How many 3-digit numbers are there? Probably 900. Just a guess. How many ways are there to arrange? Again, keyword arrange means permutation. The letters of the name Dueck. Do any letters appear twice? Then it's just going to be 5 factorial, which is 120? Yeah. Now, again, you actually have 3 different ways to do this, Brooke. That's the shortest. You could have drawn 5 blanks, and you could have said I got 5 choices for the first letter, 4 choices for the second letter, 3 choices for the third letter, 2 choices, and then 1. Or you could have said from 5 letters, permutate 5 of them. All of those will give you 120 as an answer. How many ways are there to arrange 4 letters of the name Dueck? Well, the quickest way is probably going to be from 5 letters, permutate 4 of them, arrange 4 of them. Or you could go draw 4 blanks, and you could say 5, 4, 3, 2. Is the answer 120 again? How many ways are there to arrange the letters of the name Vandervelden? Okay, do some of the letters repeat here? Okay, now we have to use our other method. It was count the total number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Holy smokes. 12 factorial over. How many V's? 2. How many A's? 1. How many N's? 2. How many D's? 2. How many E's? 3. And I think I've got all the repeats now. Only 1 R. I already did V. Only 1 L. Yeah. It's going to be that, which is, oh, don't use this calculator, Mr. Dueck. This one doesn't work well for factorials. Bring up this calculator. Option, arrow sideways, prob. 12 factorial divided by bracket. By the way, I did the factorials in my head. I know 2 factorial is 2. Oh, wait, Mr. Dueck. I know that 2 factorial is 2, and I know that 3 factorial is 6 because it's 3 times 2 times 1, and I'm lazy. Do you get 9979200? Holy smokes. 9979200. Just almost, but not quite 10 million. 5 is tough. 5 is tough. I probably won't give you one quite this tough on your test, but I am going to give you some kind of a factorial equation to solve. Now, how do I do this? On my yellow sheet, it says that NPR is n factorial over n minus r factorial. Yes? So this is going to be that all over that. Pause, and can you see how I put that together? I see a whole bunch of you writing this down, so this is one you want to try on your own later if you got it wrong. I said this PR means the first thing factorial on the top, divided by the first thing minus the second thing, the first thing minus the second thing, the first thing minus the second thing, factorial. By the way, what's a nicer way to write n minus 1 minus 2? Can I tidy that denominator up at all? Okay, so on the next line, I would say this is really n minus 1 factorial over n minus 3 factorial. That equals 210. Now what? Now I need to somehow get rid of those factorials. How? I need to expand. Which one am I going to expand? Whichever one is smaller. Sorry, whichever one is bigger. Sorry? Let's start expanding the n minus 1. So this ends up being n minus 1. What's one less than n minus 1? N minus 2. What's one less than n minus 2? Oh, and I could keep going, but if I replace the rest of keep going with that factorial, that's actually going to be convenient because what am I hoping to be able to cancel on the bottom? An n minus 3. I'm hoping to be able to go like that. So that I have now what? Now what? I think you're right, but I'm going to get rid of brackets. I'm going to go like this. Hey, you remember what we called a FOIL, right? I think was the acronym you used way back in grade 9. First, outside, inside, last. So when I multiply this out, I'll get n squared minus 3n plus 2 equals 210. Yeah? You did a whole bunch of these last year, too, in Foundations 11. Hopefully you got to the point where you can do FOIL pretty much in your head. Is that okay, Rach? Yeah? Hey, what kind of an equation is this? It's a quadratic. How do I know? It's got a squared. How do I solve a quadratic? Before I do anything else, I've got to make it equal to 0. I'm going to have to, from both sides. When I do that, I'll get n squared minus 3n minus 2 take away 210 is negative 208. Is that right? Ugh. I'm looking for numbers that multiply to negative 208 and add to negative 3. Pause. I will not accept this as an answer, but I'm going to show you how you can cheat and find the answer on your... Get your graphing calculators out, please. And press the menu button. so that you see this screen. Again, my screen looks a bit different from yours. It has the same menus in a different order. Hey, do you guys have this one here?
No.
Yeah. What do you think equa stands for? Equation solving. What menu number is it for you guys? Oh, so hit the 8. And then I think yours says something like this, yes? Simultaneous, that's when you're solving systems of equations. Remember in Math 10 and Math 11 when you were solving two equations with x's and y's, and you could either use the substitution method or the addition, subtraction, elimination method? That's great. But what we're solving right now is a polynomial equation, which is f what? You guys, I think, have more options. Mine has 2 and 3. Did yours have more options than 2 and 3? Okay, whatever. How do you know it's a quadratic? It has a, which means it has a degree of, see why okay. And so you guys did the quadratic formula last year, yes? X equals negative b plus or minus the square root of b squared minus 4ac over. Hey, that looks like a, b, and you mean, Mr. Dueck, this has a built-in quadratic formula? Yeah. What's a in our question here? What number's in front of the n? 1? What's b? What's c? How do we solve? Which is F1, yeah. I just need to make sure it's the same on yours because I got a different, I found this electronic version, but it's a different model than yours, so I'm never quite sure if the buttons are in the same place. So for you, it's also F1? What are the roots? Okay, by the way, I guess that means this. It must have been n minus 16 and n plus 13 when you factored, because what did you just tell me the roots were? What did you tell me the roots were? Positive 16 and? Which one of these is Roy's date? Sorry, Roy. Now, I'm going to give you one of these on your test. I've given you ways that you can kind of check your answer, but I'm going to expect to see the work, the factoring, and the roots. I'm saying you can use that to check your answer. In other words, to me, if you can get the setup, there's no reason that you can't get the rest of it by... There's no reason to make a dumb math mistake in my mind. Is that okay? You see what I'm getting at? By the way, if I was marking this for 2 marks, I'd probably go something like this. I'd give you a half mark if I saw that line, because that's a key start. I'd give you a half mark if somewhere along the way I saw that line there, if you were able to cancel out and realize you had n minus 1, n minus 2 left behind. I'd give you probably a half mark if I saw the quadratic. And then I'd give you a half mark for the answer, but if you forgot to reject Roy's date, I'd take off a half mark. But hopefully my dumb memory analogy, because we all want to make fun of Roy, will help you remember Roy's date, yes? Turn the page. Number 6. How many terms on the top? How many on the bottom? I think, and we did one like this when we were simplifying factorials in our notes. We did do a 4-termer. I said, you know what? If they give you 2 on the top, 2 on the bottom, in your mind, just kind of chop it in half. I'm going to get rid of that line because it covers everything. But in my mind, I'm going to see if I can do something with that 102 factorial and the 100 factorial. And I'm going to see if I can do something with that n minus 4, n minus 2. Look at the 102. Look at the 100. Which one's bigger? I'm going to expand that. So this is going to end up being 102, 101, 100. Oh, I think I'll stop there. I could keep going with a 99, 98, 90, but Brandon, I can replace that all with a factorial. Why? Because what did you see on the denominator? There was also a 100 factorial, and I can say, woohoo, those will cancel. On the top, there's going to be 102 and 101 left behind. Now let's do the algebra, the variables, the letters. I got an n minus 4 and an n minus 2. Which one's bigger? Careful. Yes, what? So I'm going to rewrite the n minus 4 factorial on the top. I'm going to leave it as is, but I'm going to start to expand n minus 2. What's 1 less than n minus 2? N minus 4. Ooh, I'm going to stop there. What do you have left on the top? 102, 101. What do you have left on the bottom? N minus 2, n minus 3. That'll get you full marks, although I'd probably take that 102 and 101 and I'd probably multiply them together as a number. What is 102 times 101? You get 1032? 10,302? 10,302? And on the bottom, if you, yeah?
I just have a question of how to get our calculator back to
Normal, like out of this menu?
Yeah, like
Menu.
No, I hit menu when you want it and it's like,
What, that appeared? Is it the same as mine?
no, there's like a little bracket or a factor.
Let me come look. Just give me a second here. So you can leave the top as 102, 101, or you can make it 10,302. You can leave the bottom as n minus 2, n minus 3, or you could write it as n squared minus 5n plus 6, which I think is what you get if you FOIL it out. I'd take either. Okay? How many marks is this worth? 2? I'd go 1 mark for the top, 1 mark for the bottom. If you got it right, 2 out of 2. Number 7, a class consists of 4 girls and 7 boys. 3 students are chosen at random. 3 students, I better make a note of that. How many ways can you select? Okay. In A, I think order matters, because is it different if you're chosen president, if you're chosen secretary, and if you're chosen treasurer? I think order matters. So the way I'm going to do this, I could say there's 3 positions: president, secretary, and treasurer. How many students do I have to choose from to be president? 11. How many students do I have to choose from to be secretary? You can't be both, right? You can only be one or the other. How many students do I have to choose from to be treasurer?
9.
So this is also the same as from 11, permutate 3 of them. It's going to be 90 times 11, which is 990. Okay. So I'm going to, by the way, I like number 7, I like number 7, I like number 7. On your test, I'm going to give you some kind of a committee question, because Rosanna, much like for permutations, it was easy. We did so many word questions because it was easy to turn a question into a word. For choose, it's pretty easy to turn a question into a committee question if you're clever. In fact, we turned card questions into committee questions, but instead of having boys and girls in our bucket, we had clubs and spades and diamonds and hearts, but it was the same idea, right? Any 3 people. Any restrictions here? Any 3 people? From 11, choose 3. Oh, wrong one. 11, choose 3. 165 is correct. C. Okay, now we're breaking this up into subgroups. What's my tool? What do I use when they give me subgroups? What's my strategy? I don't draw a blank. I don't go to a Scrabble bag. What have I given you? Bucket. So I'll do that over here. We have boys and girls. How many girls? You know what, Mr. Dueck? Since they went girls and boys, why don't you be clever and go in the same order? That way you're less likely to make a dumb mistake. 4 and 7. We want 2. By the way, did I actually need to tell you that we were picking 1 boy? Or since I told you we're picking 3 people, if I told you 2 girls, is it fair for me to ask you to reason that there must be 1 boy? I'll probably do that on the test. But it looks like it's going to be 4, choose 2. Is that from in here, that whistling noise? And if it is, can it stop? $42? Yeah? What's the key word in D? What does that mean? List the cases. Now, I still see a bunch of you trying to do this too quick. It is well worth saying at least one means 1 or 2 or 3. List the cases. I can probably use the same bucket. And in fact, I've already done 2 girls. That was going to be, I've done the committee for 2 girls. That's 42. 1 is going to be 1 and 2. That's going to be 4, choose 1, and 7, choose 2. 3 is going to be 3 and none. It's going to be 4, choose 3, and 7, choose 0. And now I can quickly go 4, choose 1, 7, choose 2 is 84. 4, choose 3, and 7, choose none. 4. 84 and 42 is 126. 130? For 2 marks, I would probably give you 1 mark if I saw that, and 1 mark for the answer. So 1 mark if I saw that you got all 3 cases. What if it had been at most 1 girl? What are the cases? 1 or 0. Yeah, don't forget 0 if it's at most, right? Could be no one. Order matters in a blank, and order does not matter in a... Which one of the 2 we've been looking at, which one does order matter in? Permutation? Doesn't matter in a combination. A new Toronto license plate has the format: the first 4 characters are letters, the last 3 characters are numbers. How many licenses can be made if repetition is allowed? And you can also use an I or an O, because we said sometimes some provinces don't use I's and O's because it look like 1s and 0s. We're saying you can. You know what? This is a job for the fundamental counting principle. Draw a blank. 1, 2, 3, 4 characters. 1, 2, 3 characters. There's the license plate. The first 4 characters are what? Letters. How many letters are there? Oh, hang on, Mr. Dueck. Put the 26 on top of the blank, right? 26, 26, 26, 26. The last 3 characters are numbers, are digits. How many numbers do I have to choose from? Repetition is allowed, right? You know what? The short way to type this in, I think, is going to be 26 to the 4th times 10 to the 3rd. I think Ontario has 7 character license plates like this. How many cars can they insure? You say a lot. We always thought this was lots, but we're finding out, again, IP addresses, when they first set them up, were supposed to last until, I think, 2030. And we ran out 2 years ago and had to go to IP version. We went from IP4 to IP6. We skipped version 5 because that was going to fill up too quick. So anyways, 456-97600. 456-976-000. 3 zeros? Yeah. 456,976,000. Probably enough for this foreseeable future, but who knows? Oh, what if we're not allowed to repeat? $26, then 25, then. You know, a short way to write that is going to be from 26 permutate 4 and 10, 9, 8. A short way to write that is going to be from 10 permutate 3. You can either do the top one or the bottom one or some combination. And again, Caitlin, you'll notice my fallback, if I come to a weird question that I haven't seen, my fallback is usually draw blank fundamental counting principle, but then often partway through I'll go, aha, I see a shorter way I could have done this. 26p4 and 10p3 and means multiply. 258 33600. Hey, what if I instead asked how many of these do repeat? I think if you go this minus that, whatever's left must be repeating because those are the ones that don't repeat. And last one, pathway. Is this a regular pathway question or an irregular pathway question? This is a regular one because the rectangles don't overlap. By the way, you can use Pascal's to do this, or you can use choose. I'm going to use choose. Right, down, down, down. The first rectangle is going to be 5 factorial all over 2 factorial, 3 factorial, and right, down, down, 3 factorial all over 2 factorial. And I even thought 6. I said 2 times 6, and I hit 3. My brain works strangely. 3 factorial divided by 2 factorial, which really is just plain old... syntax error. Is the answer 30? Okay. And if you want to get there with Pascal's, it would be 1, 1, 1, 1, 2, 1, 1, 3, 3, 4, 6, 10, 10, 10, 10, 20, 30. Either way gets you there. Can you give yourself a nice clear score out of, count 'em, 18, please? Y'all ready? I'm going to get through about half the lesson today, and I'll finish the lesson off on Monday. This is also cool in a nerdy kind of a way. And this is also a great shortcut. Today we're going to be learning about one of the more impressive sounding things you'll be learning today. We're going to be learning the binomial expansion theorem. Rosanna, what did you learn in school today? Mummy, 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 I learned the binomial expansion theorem. Oh, Rosanna, you were ever so clever. Sounds impressive. By the way, what's a binomial? You learned this in high school. What's a binomial? Okay, 2 terms in a bracket. Expansion, that's when you were multiplying binomials together. So what we're going to be learning, this is a shortcut for expanding binomials, and it's pretty cool. You ready? We're going to start out looking for a pattern. So I wrote down here, investigate the patterns in binomial powers. I need you to stop talking, please. Thank you. It says expand and simplify each of the following powers of the binomial a plus b. A plus b squared. What does that mean, first of all? The answer, you do not simply go, hey, Mr. Dueck, can't I just go squared, squared? No. It's this whole bracket squared, which means what? If I was evaluating this, if I was expanding this, how would I do that? I would write the bracket out twice. And then I would actually do the FOIL. I would get a times a, which is what? I would get a times b, which is what? Oh, but wait. I would also get another a times b. See it there? So it's actually ab plus ab. What is ab plus ab? And then at the very end, I would get a b times b, which is what? You did that, I think, in Math 9. You start doing FOIL. In Math 10, we say, hey, what if instead of a 2, there's a 3 there? Instead of writing the bracket out twice, how many times would I write out the bracket? So I would go like this. I can't go, don't write this down, don't write this down, don't write this down. I can't go chunk, 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 or something like that. What I would now do is I would multiply these two brackets together, get an answer, and then multiply the first bracket. And hey, wait a minute, I have multiplied these two brackets together. It's sitting right there in red. A plus b times a plus b is a squared plus 2ab plus b squared. I would rewrite this as the first bracket would stay. The second two brackets are a squared plus 2ab plus b squared. By the way, this is the last time we're going to do this. We're going to look for a pattern. There is a great shortcut. And then, Rosanna, I would go multiply the a onto everything. Multiply the b onto everything. And then gather like terms. I'm just going to tell you what the simplified polynomial is. If you do this, you will get a cubed plus 3a squared b plus 3ab squared plus b cubed. Trust me. By the way, can you see this would be a fair amount of work to get that? You'd be doing lots of FOIL, multiply, and then gathering like terms. And it only gets worse if the exponent is a 4. Because if the exponent was a 4, this actually means a plus b, a plus b, a plus b, a plus b. Yuck. Lots of work. Lots of work. But I'm going to tell you the answer. I'm going to do it in my head. Really, Mr. Dueck? Yep. Watch. The answer is going to be a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. How did you do that in your head, Mr. Dueck? Depressingly, stinking easily. It's easy, if you know the shortcut. So write that down, and then put your pencils down, and we're going to turn our brains on. But write that down. In part B, Caitlin, I said, what pattern do you see in the, and then what's the first thing I asked you to look at? What pattern do you see in the powers of? Hey, look. What do you notice about the exponent on the a? What do you see? Goes down by 1. So what do I have here? A to the? A to the? A to the? 2. A to the? And trick question, a to the? 0. And anything to the 0 is 1, so we don't bother writing it. By the way, what number is on the first a? What number is right there? 4. If I was expanding a plus b all to the 5th, what would the powers of a do? More specific. A to the 5, then. That, I mean, I'm going to argue that's a fairly easy pattern to keep track of. Like I said, it is possible to do this in your head. You okay with that? Hey, what happens to the powers of b? They start out with b to the 0, then 2, 3. Okay. Now, what about the coefficients? What number is in front of the a right here? It's invisible. You know what? Let's all of us right now write that in. Let's put a 1 there and a 1 there. Tiffany, what?
It's the triangle thing that we learned about last class.
What triangle did we learn about last class?
Pascal's triangle.
Hang on, let's see. Wait a minute. Let's go back up here. Shh. Are you saying this is 1, 2, 1, and that was a row of Pascal's triangle. And this was 1, 3, 3, 1, and that was the next row of Pascal's triangle. Don't believe me? Don't 1 plus 2 equal 3. Don't 1 plus 2 equal 3, and 1s were going down the sides. Are you saying that it's, oh, hey, look. The 1 goes down, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. Are you saying it's Pascal's triangle again? What, Sean? That is nerdily cool, but not only is that nerdily cool, that's hugely useful because it gives us a shortcut. Because, wait a minute, didn't we know how to find any term we wanted to of Pascal's triangle using choose without writing all the stuff above it? And we spotted a pattern for the exponents, yes? We can put this all together and we can find a way to expand binomials. That's why this is called the binomial expansion theorem. Almost in our heads. So, what pattern do you see in the powers of A? Going down by 1. What pattern do you see in the powers of B? Start at 0. Go up by 1. What pattern do you see in the numerical coefficients? Pascal's triangle. Christy, you had your hand up and I ignored it. You have a question? Or? Okay. Pascal's triangle. Now, before we go further, staying on this page for a second, what's my exponent? 4. 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. Because that was how Pascal's triangle worked, wasn't it? If you were dealing with a 4, you had to remember to start counting at 0, but it was the chooses. So, it says confirm your observations by expanding and simplifying a plus b to the 5th. Okay. A plus b to the what? So it's going to be a to the 5th, leave a space. A to the 4th, leave a space. A to the 3rd, leave a space. A to the 2nd, leave a space. A to the 1, leave a space. That's what the A's are going to do, right? What are the B's are going to do? The opposite, but starting at what? So no B. B to the 1, B to the 2, B to the 3rd, B to the 4th, leave a space, B to the 5th. By the way, what do the exponents in each term add to? What do the exponents in each of those terms add to? 5, there's a built-in error check. They'll always add to your original power on your binomial. What do they add to? What do they add to? Because what's right here? What's right here, Sean, for a reason? Oh, that means the coefficients are going to be 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5. That's how Pascal's triangle worked. That was our shortcut for finding a row of Pascal's triangle if we didn't want to write everything above it. Oh, and then put plus signs in between the terms because you're expanding a binomial. There was plus signs when you gathered like terms. Final answer, almost in our heads, showing no work. We're showing one line of work. What's 5 choose 0 on your calculator? What's 5 choose 0? Oh, 1, so it's just going to be a to the 5th plus. What's 5 choose 1? What's 5 choose 1? You need to do this on your... What's 5 choose 1? Come on. I need some feedback here, folks. 5, and then the a to the 4th, and the b drops down, plus. The third term, what's 5 choose 2? 10, a cubed, b squared, plus. What's 5 choose 3? The same as 5 choose 2. I could probably be clever and not bother retyping it. Plus, what's 5 choose 4? I think it's the same as 5 choose 1, so it's going to be a plus 5 choose 5 is 1. That, what I wrote in black, is the expansion of a plus b to the 5th. And to do that by hand, if you actually FOILed it out, would probably take about 10 minutes, and the odds of you making a mistake are pretty high, because I think you end up doing about 40 calculations grand total. Okay. Nice shortcut. Nice shortcut. Now, that's when I have an a plus b, when I have very simple terms in the brackets. It's the same procedure when the terms get more complicated. Watch. So visualization, a plus b to the 4th is 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. A to the 4th, a to the 3rd, a to the 2nd, a to the 1, nothing. B to the nothing, b to the 1, b to the 2, b to the 3, b to the 4th. Example 1. Expand. X plus 1 to the 4th. What's sitting where the a is? So let's put a little tiny a right here. What's sitting where the b is? 1, positive or negative? Because sometimes there's going to be a sign from it. Okay, so that's b. What's my exponent? 4, so it's going to be what choose what choose what choose what. What's my coefficients going to be? What's my exponent? 4. So the coefficients are going to be 4 choose 0, leave a space. 4 choose 1, leave a space. 4 choose 2, leave a space. Mr. Dueck needs to write this a little smaller. 4 choose 0, leave a space. 4 choose 1. 4 choose 2. 4 choose 3. 4 choose 4. Is that okay? A to the what, a to the what, a to the what, a to the what? 3rd, 2nd, 1st, none. B to the what, B to the what, B to the what, B to the what? B to the none. 1, 2, 3, 4. There's our template. Now let's actually fit in this particular question. Some of it we're going to do in our calculator, some we're going to do in our heads. What is 4 choose 0? 1. What's a in this question? What's a in this question? X to the 4th. Right? Plus. By the way, on the next line in our final answer, what is 1 times x to the 4th? If I tidy all that up, that's just, I think, plain old x to the 4th. That's going to be our final first term. What is second term? 4 choose 1. 4. What's a? X to the 3rd. What's b? 1 to the 1. By the way, on my next line, there's going to be a plus sign. It's going to be, if I look at my numbers, I think it's going to be 4 times 1 to the 1, or just plain old what? What is 4 times? Well, first of all, what's 1 to the 1? Times 4?
4.
So 4 and an x cubed. Plus. Next term, what's 4 choose 2? What's 4 choose 2? 6. And then there's going to be an a squared, but what's sitting where the a was? X. And there's going to be a b squared, but what's sitting where the b was? 1 squared. Oh, you know what? When I tidy this up, I think it's going to be, see the numbers, see the numbers, see the numbers? 6 times 1 squared, just plain old what? What? 6? and then x squared. What I'm preparing you for, Jordan, is on the next one, instead of a 1, what do I have sitting there? A 3. Where all these 1s are, there's going to be 3s. I'm going to have to do some math with the 3s as well. The next term, 4 choose 3. 4 choose 3. 4, x to the 1, 1 to the third. Or when I tidy that up, it's going to be just plus 4x. Yeah. Plus the last term, 4 choose 4. 1. What's b? Also 1 to the fourth. What's the last term work out to? What is 1 times 1 to the fourth? Okay. In black, that is the expansion of x plus 1 to the fourth, using my a and b as a temporary template and just translating it all the way through. And I'm going to tell you that's way faster than foiling it out. And in fact, when you get the hang of this, you'll be almost, not quite, almost doing this as fast as you can write. By the way, how many terms are there in my final answer? Count. 5. What was the exponent? 4. Hey, what if the exponent was a 6? How many terms do you think there'd be? 7. What if the exponent was a well, when the exponent was a 3, how many terms did I get? 4. Oh, you always get one more term than you have exponents. Why? Because we start counting with our chooses as at what? 0. Actually, that makes sense now because I'm starting my counting from 0. There should be one more than n, right? Let's try another one. So, B. What's sitting where the A is? What's sitting where the A is? An X? What's sitting where the B is? Okay. What's my template going to be? Well, it's going to be, what's the exponent, Jordan? 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. Jordan, what's the exponent?
4.
A to the fourth, third, squared. Whoop. 1, none. Jordan, what's my exponent?
4.
0, 1, 2, 3, 4. Right?
Yeah.
Now let's, using that as my template, plug in specific to this question. Let's see. 4 choose 0. I think that was 1. Yeah? And a to the fourth, what's sitting where the x is? What's sitting where the a is? An x to the fourth. And in fact, on my next line, this is just going to become x to the fourth. Plus. Hey, what's 4 choose 1? 4. And then it says a to the third. A, there's an x sitting there. Oh, what's b this time? What's b? See it? You know what? When I simplify this term, what's it going to end up being? What's my coefficient going to end up being? Do you see the 12? Right, Emma? There's going to be a 12 and an x cubed. Plus. Hey, what's 4 choose 1? Sorry? 4? Sorry, 4 choose 2. I'm sorry. I'm on the next one. What's 4? Line this up properly, Mr. Dueck. Hey, what's 4 choose 2? I ready to 1, 2. I'm on this one, right? 6? And then it says a squared. That's going to be x squared. And then b is 3 squared. Hey, what's the coefficient going to be for the next term? I can't tell if I've totally lost you or if you're with me.
36a squared.
What's 3 squared? 9 and a 6 in front?
54 squared. Where we get the 6 from?
4 choose 2?
Oh.
Right? Is that okay?
Yep. What it when is the bracket ever after x? After 6? Is that a squared or x squared?
Well, it's a squared, but what's sitting where the a is? An x.
What did you write down x right?
Here?
Yes.
X, because that's what it really is. We're using this as our template.
I think the bracket after 6.
That's an x.
Okay.
Yeah. Sorry, I didn't see what you're asking.
Okay.
Okay? So, Sebastian, we're doing this one now?
Yep.
Okay, you ready? What's 4 choose 3?
4.
Okay. And then there's an a. What's sitting where the a is in my original? What's sitting where the a is in my original? And then there's a b. What's sitting where my b is in the original? A 3 to the what? Third, yes?
Yeah.
Hey, what's my coefficient going to be of my next term? Can you see there's a 3 cubed and a 4. 3 cubed is 27 times 4. Ellen? There's going to be a 108. And then I guess just that single x would drop down like a domino, yes? Plus. What's the last term? 4 choose 4. I think that's 1. And then it's going to be 3 to the 4th. What is 1 times 3 to the 4th? What's the coefficient here? 81. X plus 3 all to the 4th. If you expand it, you'll get x to the 4th plus 12x cubed plus 54x squared plus 108x plus 81. C. We're going to skip. We're going to go to D. Except instead of a 4, make that a 5, please. Okay. Instead of a 4, make that a 5, please. By the way, what's the exponent? 5. How many terms? I'm going to get 6. All right. What's the exponent? What's the exponent? So what choose what? What are my coefficients starting out going to be?
5 choose 0.
Good. So there's going to be a 5 choose 0, leave a space. A 5 choose 1, leave a space. 5 choose 2, leave a space. 5 choose 3, 5 choose 4, 5 choose 5. What's my exponent? 5. So it's going to be a to the 5th, 4th, 3rd, 2nd, 1, none. Yep. Yes. Yep. The exponent tells you what we start with. What if, Brooke, what if it had been a 7 there? It would be 7 choose 0, 7 choose 1, 7 choose 2, and it would be a to the 7th, 6th, 5th, 4th, 3rd, and going off the page. Brooke, what's my exponent though, really? So it's going to start with the b's, b to the 0, 1, 2, 3, 4th, 5th. Just got to remember to start counting at 0 if you're going up, or end at 0 if you're going down. Except, look at my binomial. What's sitting where the a is? So let's actually write this, because this is a tougher one. I'm going to write a equals 4x. What's sitting where the b is? Okay. Because I want to, I'm expanding. right? I gotta plug in for the, wherever there's an A, eventually I'm gonna put a 4x there. Wherever there's a B, eventually I'm gonna put a negative 3 there, because the template that I gave you works for A and B, but this doesn't have an A, this is more complicated. Ready? Hey, what's 5 choose 0? This is gonna be 1, and then what to the 5th power? 4x. Now, what's that going to end up being on my final line? First of all, I'm going to have to go 4 to the 5th power. What's 4 to the 5th power? Times 1. Oh, that's not going to change anything. So it's going to be 1,024. And then how many x's will I have dropping down like a domino? X to the? That's the first term of this expansion. Let's do the second term. 5 choose 1. And then there's going to be a 4x to the 4th and a negative 3 to the 1. There's my a to the 4th, b to the 1. What am I going to get for a coefficient? Well, there's going to be a 5, there's going to be a 4 to the 4th, and there's going to be a negative 3 to the 1. That's the numbers, that's the numerical part, that's the coefficient part. See it? In my second term, it's going to start with a negative 3,840. It's going to be a minus 3,840. X to the what? X to the what? 4. Let's do the third term. Yep. The negative 3,840? I went number times number, but that's a 4 to the 4th, yes? Times number. So I went 5 times 4 to the 4th times negative 3 to the 1. Okay? Let's do another one. We keep going. Ready, Angel? I'm going to pick on you in love. Brooke, the first thing I'm going to write for the next term, look. We're doing this one? Yeah. Brooke, we're doing this one? Yes? What's the first thing? Can you read this to me, please? What is that as a number? Can you evaluate that on your calculator? So there's going to be a 10. Then what's the second thing? A to the 3rd, except what's sitting where the A is? Okay, so it's going to be 4x all to the 3rd. And then the last thing, b squared, but what's sitting where the b is? Okay, now let's evaluate the numbers. In the front, I have a 10 times. Then in the first bracket, can you see I have a 4 to the 3rd? Times. In the second bracket, and I'm going to have to put it, folks, look up. I'm going to have to put, anytime I have a negative and I'm using an exponent, I got to put the negative number in brackets to the exponent squared. What's the coefficient of the third term going to be? 5,760? Positive or negative? Positive, which says to me, put a plus sign. Oh, change colors, Mr. Dueck. Says to me, put a plus sign. What did I say it was? 5,760. Oh, and Brooke, what's the exponent on the x that's going to drop down? There's the next term. Halfway through. Halfway through. What's the next one going to be? Which is? I think also 10. And then it's going to be 4x all squared, negative 3 to the 3rd. Which is going to be 10 times 4 squared times bracket negative 3 to the third. The coefficient is going to be negative 4,320 minus 4,320 x squared. You guys okay with where we're getting this from? You got to go be careful, but it's systematic. And again, it's way faster than doing this by hand and foiling all this out. Next one, which is 1, I think. Oh, 5, you're right. I'm sorry. 5 choose 5 is 1. I did it again. Good gosh. 5, and then it's going to be 4x to the 1, negative 3 to the 4th. Coefficient looks like it's going to be 5 times 4 to the 1 times negative 3 to the 4th power. 5 times 4, does to the 1 power make a difference at all? No. Times negative 3 to the 4th power. I get a coefficient of 1,620. And it looks like I'll have x to the 1, or just plain old x. Last term. I got to move down a little bit. 5 choose 5. 1. B to the 5th. Negative 3 to the 5th. It's going to be 1 times bracket negative 3 to the 5th. The final term is going to be a minus 243. There it is. (4x minus 3 all to the 5th power) is that. And I didn't need to FOIL it out to do it. Silke, how many terms are there grand total? 6 when there's an exponent of? So if I gave you to the 9th, how many terms are there grand total? 10. That's too much writing. You know what I'm going to do on the test? I'm going to give you a 9, but I'm going to say, just tell me the first 3 terms. Or the last 3 terms. Something like, for example, in E. E, I'm giving you to the 5th power. I'm saying write the first 3 terms. Yeah. Now, we're going to temporarily pause here. If you want to get a bit of a start, though, I think in the homework is attached, by the way. I think you can probably do right now, you can try number 1 and number 2 and number 3 if you're feeling adventurous. But I'm going to continue with this on Monday, so if you don't get to it, you'll get time to work on this on Monday. And then we're going to ask ourselves, okay, what if I don't want all of the terms? Hey! Hello? What if I don't want all of the terms? What if I don't want the first 4 terms? What if I just want the 7th term? Can I find the 7th term without having to write out the first 6, please? And there is. Binomial expression.